Hello, my name is Matthew, and today I will be doing question 6 from section 4.2. So we have a car traveling along a straight road and it's braking, and its velocity is measured at several different points in time, and those points are given in the following table. So we have the seconds in intervals of 0.3, and then the velocity in feet per second. And the first question, or the first part, was to just graph it. As you can see here on the right, we have the time in seconds on the x-axis, and the velocity in feet per second on the y-axis. So we go on to the next question, which asks us to estimate the total distance traveled during the car the time breaks using a middle Riemann sum with 3 subintervals. So first off, we have our 3 subintervals represented by the orange rectangles, and given the total time of 1.8 seconds, our subintervals are then 0.6 seconds long. And so the middle of the interval falls on the middle coordinate, which is 0.3 seconds, and then 0.9 seconds and 1.5 seconds. So we end up having the first rectangle of 0.6 seconds times a height of 88 feet per second, which gives us a total area of 52.8 feet. The second one is 0.6 seconds times 59 feet per second, which gives us 35.4 feet total. And then we have 19 feet per second times 0.6 seconds with 11.4 feet for the total of that. Combine those all together, we have a total area of 99.6 feet. Now we move on to the next question. So the next question just asks me to split the on the left Riemann sum, the right Riemann sum, and then I average the two of them. So here for the left Riemann sum, I just took the heights of the rectangles according to the leftmost point of each rectangle. So we have 100 feet per second times 0.3 seconds, and that gives us 30 feet. And then we have 88 feet per second times 0.3 seconds gives us 26.4 feet. And then we have 74 feet per second times 0.3 seconds, and so on. We get these numbers, and those add up to be 104 feet, which is also an overestimate. And again, being the left Riemann sum, that means the left-hand corner of the rectangle intersects right here, so we use the points at 0 and 0.3 and then 0.6 and then 0.9 and then 1.2 and then 1.5. I also should mention we're using 6 intervals now instead of just 3. Then for the right Riemann sums, we use the rectangles when their rightmost points intersect with the line. So here we have our intersects at 0.3 seconds, 0.6 seconds, 0.9 seconds, 1.2 seconds, 1.5 seconds, and 1.8 seconds. We have our totals right here. The last rectangle is going to be 0 feet per second because the Riemann sum for that specific interval from 1.5 to 1.8 is just going to be 0. And that totals up to be 84 feet, which is an underestimate. Then when you average the two of them together, you get 99 feet, which is pretty accurate to what we estimated above. Now on to the last question, which asks us what the maximum possible distance that the car can travel is going to be over the interval from 0 to 1.8. Now fortunately, this is pretty easy for us because the entire graph is shaped like a triangle. So what we do is we just find, we're also assuming that it's a linear equation decreasing, so that we can just assume this would be one straight line, and we just find the total area under the entire equation from 0 to 1.8. So we just have 100 feet per second as our height times a width of 1.8 seconds, and that when you divide that by 2, you end up with 90 feet. So what this means is that the car, at the most, assuming this is a perfectly linear graph and was never accelerating at any point during the process, at most could have traveled 90 feet. Well, thanks.